this video, we're going to be talking about the different characteristics of exponential functions. We've already gone over each of these characteristics individually, but now we're just finding them all together on one graph. So on example 1, we have this exponential curve, and we want to find the domain. Remember that your domain are your x values from left to right. My graph is going to the left forever, so that's going to negative infinity. My graph is going to the right forever, so that's going to positive infinity. So my domain from left to right is from negative infinity to positive infinity, which is the same thing as saying all real numbers. Remember that this symbol right here is the mathematical symbol for our all real numbers. It is a capital R with an extra line. Your range are your y values from the bottom of your graph to the top of your graph. The bottom of my graph is my asymptote. That is this line right here. My asymptote is where y is, well, let's see, -1, -2, -3, -4, -5, -6. So this is where y equals -6. The top part of my graph, well, that's going up forever, so that's going to infinity. So my range from the bottom of my graph to the top of my graph is from -6 to infinity. -6 gets a parenthesis because it is a dashed line. We will get very, very close to our asymptote, but we will not cross or touch it. As an inequality, our curve is above our asymptote, so y is greater than our asymptote. We said earlier that our asymptote was at y equals -6. To figure out if your graph is increasing or decreasing, you trace your graph from left to right. From left to right, my graph is going down, so this is decreasing. Now, normally for growth or decay, you look at your b value. In this example, they didn't give us the equation. When they don't give you an equation, what you want to do is you want to look at your curve in relation to your asymptote. Your curve will either grow away from your asymptote or it will decay to your asymptote. So if the gap, if we look at it this way, if this gap gets smaller, then it's decaying. And if that gap from left to right gets larger, then it's growing. So this gap is getting smaller and smaller from left to right, so this is exponential decay. And then for end behavior, as x approaches negative infinity, that's telling us to look at the left side of our graph. The left side of our graph is pointing up, so that is going to positive infinity. And as x approaches positive infinity, this is telling me to look at the right side of my graph. The right side of my graph is on my asymptote. My asymptote is at -6. Let's try this again with example 2. So on example 2, we want to find our domain and our range. So my domain is my x values from left to right. So here, my graph is going to the left forever, so that's going to negative infinity. And my graph is going to the right forever, so that's going to positive infinity. Negative infinity to positive infinity is the same thing as all real numbers. Your range are your y values from the bottom of your graph to the top of your graph. The bottom of my graph is going down forever, so that's going to negative infinity. The top of my graph is my asymptote. Here, my asymptote is at 1, 2, 3, 4. Y equals 4. So my range from the bottom of my graph to the top of my graph is from negative infinity to 4. For my inequality, my curve is below my asymptote, so y is less than 4. We said earlier that our asymptote was y equals 4. For increasing and decreasing, you trace your graph from left to right. From left to right, this graph is going down, so this is decreasing. To figure out if it is exponential growth or decay, I'm going to look at my gap. And my gap between the curve and the asymptote is growing from left to right, so this represents exponential growth. For my end behavior, as x approaches negative infinity, this is telling me to look at the left side of my graph. The left side of my graph is on my asymptote. My asymptote is at 4. As x approaches positive infinity, this is telling me to look at the right side of my graph. The right side of my graph is pointing down, so that is going to negative infinity.